Okay, this is 6th grade, chapter 7, multiplying fractions. And actually, it's the whole chapter is multiplying and dividing fractions. So the first one, 7.1, is multiplying fractions and whole numbers, page 341 in the book. So I'm writing this up here for you to turn to page 341. There's a lot of you who aren't following along in the book, so make sure you do that. Key vocabulary, first off, a whole number. A whole number are the numbers that start with 0, 1, 2, 3, 4, and so on. There's nothing in between. There's no fractions. They're the whole thing. So like you get the whole pizza, the whole candy bar. No halves, no thirds, no fourths, and so on. So those are the whole numbers, the set of numbers that start with 0, and you just count by ones. Compatible numbers are numbers that go in evenly. For example, I would say that 3 and 12 are compatible because 3 can go into 12 4 times. Okay, so compatible numbers divide evenly into each other. All right, and we did that when we were estimating. If you remember way back in the beginning, if you had to estimate, you thought of compatible numbers, things that make it easy for you to do the algorithm or the dividing. So the key concept right here, you're writing this box for me, okay, right here. The key concept, multiplying fractions by whole numbers. So to multiply a fraction by a whole number, you multiply the numerator by the whole number and write the product over the denominator. Okay, so let me put an example down and read through that. So 2 times 3/7. So this is the whole number, the 2. There's our fraction, 3/7. So to multiply a fraction by a whole number, multiply the numerator by the whole number. So here's our numerator, the 3. We multiply it by the whole number, which is 2. So we get 6. And then write the product over the denominator. We don't multiply it, we just notice the bottoms always stay the same when we're adding, when we're multiplying, in this case with the sevenths. So we have 2 times 3/7 is 6/7. Top number times the whole numerator times the whole number, bottom number stays the same. So algebra, this is just letters, would be A times B over C would be A times B on the top over C. Okay, so let's do some of these. So multiply the numerator by the whole number. 6 times 3 would be 18 over 4. Okay, and then you can't leave it like that. So this one actually has got 2 things you could do to it. Let me go back. 18/4. I'm looking at it going, you know what? I can chop those both in half. I could divide them by 2, which would be 9/2. But the numerator is still bigger than the denominator, so you would have to divide that. How many times does 4 go into 9? Or excuse me, 2 go into 9 4 times, which is 8, and there would be 1/2 left over. If you can't do that in your head, this is what I just did. 2 goes into 9 4 times with the 1, and then the bottom stays the same. It was a 2, so it stays the same. Okay, so this one, 2 times 3, you just multiply the top, leave it over the bottom. Then you decide, can I reduce? I can divide both of those by 2, so the answer would be 3/4. A lot of times people want to take 2 times 3 and 2 times 8, but you don't, only right there, and then the bottom stays the same. So here we go, 2 times 4, and the 3 stays the same. How many times will 3 go into 8? 2 times, which is 6. That'd be 2/3 left over, and all I did was this division. And you should almost get to where you can do that in your head if you hear me talk. How many times does 2 go into 8? Or 3 go into 8? 2 times, which is 6, and then 7, 8 count up. There's 2 left over. So again, top times the whole number, so that would be 9/10, and we can't simplify it. This one, 9/8, 3 times 3, and that's 1 1/8. Done. What? 3 3/8. That's not right. Hold on, maybe they wrote, sometimes they write the wrong. 3 times 3 is 9, isn't it? Oh, The book, they have it written wrong right here. The book has this as a 9, which would make that 27 over 8. It goes in there 3 times, which is 24, and there'd be 3 8s left over. So I did it right for the problem they wrote, but in the book it's got a 9 there. Okay, number 3, you would multiply these, so it'll be 42 over 5. 5 goes into 42 8 times, which is 40, and there'd be 2/5 left over. This one, 5 times 3 would be 15 over 6. You know, I'm going to reduce that first by dividing them by 3, and that's 2 1/2. So write all that, just write your answer out, and then show you're simplifying. So the guided practice number 5 says, look at the results in example 2. Which product is greater than 2? Name the 3 other fractions you can multiply by 2 to get a product greater than 2. So we'll go back to the result of example 2, which was 2 2/3. Name 3 other fractions you can multiply by 2 to get a product greater than 2. Okay, so anything, in order to get a product greater than 2, you have to multiply by a fraction bigger than 1, because 2 times 1 is 2. And they want us to get something greater than 2. So we need a fraction greater than 1. So as long as the top number, like 5 over 3, that's bigger than 1, that would get us bigger than 2. 6 over 4, 7 over 5. Any of those. There's about a million answers that you could put there. And there's just a couple that they have. Okay, example 3, party music. You are choosing 18 CDs to take to a party. You want 2/3 of the CDs to have dance music. How many dance music CDs would you choose? So this is what I see out of that, is 2/3 of the 18 that you want to take need to be dance music. So in math, 99% of the time means to multiply. So right there, that should look familiar. There's something we've been doing in the example. So you'll just take 18 times 2, which is 36, over 3, and 3 goes into 36 12 times. So you'll have 12 songs that are dance music. And there's we're not going to do the models. We're just doing the math right here. Okay, there it is. You have 15 CDs. Each CD case is 3/8 of an inch wide. Estimate how wide a space you would need to fit on a CD rack for all 15 CDs. Okay, so they're each 3/8 and there's 15 of them. So we're going to multiply that times 15. So that's going to be 45 over 8. Goes in there 5 and 5/8 in its inches. So it has to be at least 5 and 5/8 inches. So it says to estimate, so actually maybe we should have rounded, but that means about 6 inches would be fine. See how they did it. Same way. Oh, there's their compatible. Replace it with a compatible number. Okay, use mental math or a model. So here's what they're having you do on these. Check this out. 3, the numbers are big. Okay, of means to multiply. So what we're going to do, instead of taking 3 times 28, another way to do this, let's do one that we did earlier. Let's do it this way. Half of 6. Well, half of 6 is 3. You probably all could do that way. Half of 6. And I showed you of is a multiplication problem. So you could take the way we learned at the first part is 6 times 1 is 6 over 2, which is 3. But another way to do these problems is to take the whole number and divide it by the divisor. Excuse me, by the denominator. So 2 goes into 6 3 times, and 3 times 1 is 3. And I guess here was the pictures they were showing. You have 6 things. 1, 2, 3, 4, 5, 6. Okay? You split them into groups of, excuse me, that doesn't go there, in a group of 2. So there'd be 3 in this group and 3 in this group. So the bottom number tells you how many groups to split the whole number into. The top number tells you how many of those groups will answer the question. And one group has 3 in it, so the answer would be 3. So this means we're going to take 28 and we're going to split it up into 4 equal groups. Well, when you split it up into groups, you divide. 4 goes into 28 7 times. So there will be 4 groups of 7. So we want 3 of those groups. So 3 groups of 7 would be 21. Now you can still take 28 times 3, which is 84 over 4, and then divide that out, and that would be 21. But this is just another way, a shortcut kind of way, where we can do it more mental. So you divide here, then multiply. And at the beginning, same thing. We were multiplying first, then dividing. That's what we were doing at the beginning of this lesson. So it doesn't really matter which way you go with it. Let me erase my slide here. So even though the whole number's over here, same, 36 times 2 is a pretty big number. We could do it if you want to multiply that, then divide by 9. But let's divide first, because I see these are compatible. 9 goes into 36 4 times. 4 times 2 is 8. So you can either multiply then divide, or divide then multiply. And it just depends on what direction. You notice I'm going in different circles. If I multiply first, I multiply right here, then I divide. Here I divide, then I multiply. So it doesn't matter as long as you go in the right order. Now estimate, this means I need to make, if I'm going to divide 5 into 26, I know it doesn't go evenly. So I need to make this compatible with 5. The closest number to 26 that 5 will go into is 25. 5 goes into 25 5 times. 5 times 3 is 15. So I estimate it's close to 15. Suppose you have 38 CDs. Estimate how much space you would need to fit all 38. Remember, the CDs are about 3/8 inches wide. So we're taking 3/8 times 38. I want to divide 8 into 38, so I need a number compatible with 8, which is 40. 8 goes into 45 times. 5 times 3 is 15. So you would need about 15 inches. There we go. Okay, so 2 ways to do it. You either multiply first, then divide, or divide, then multiply. Make sure you understand the order. If you're not sure, please ask before you start, or check out this podcast again, and we will see you next time.